Welcome and thank you for joining. My name is Dave Moser. I am an AWS Senior Solution Architect, and I'm here to talk to you today about building a full stack Apple CarPlay app with Swift and AWS services. Now, if you joined this session, you may have some familiarity with either developing Apple iPhone applications or even CarPlay applications. Today, I want to walk you through how you can build such an app using full stack Swift. So using Swift on the front end of your application, as well as in your backend services. We're going to look at how you do that with Lambda functions. We're also going to take a look at the newly launched Amazon location service, which allows us to pull in location information and functionality from a managed service in AWS. We'll take a look at AWS AppSync, which is going to function as our API layer, which is our managed GraphQL service. We'll also talk about AWS Amplify, which is AWS's mobile tools and functionality that you can pull in to build such applications. And finally, we'll look at the AWS Cloud Development Kit, or CDK, which is how we can deploy our infrastructure as code. Now, I'd like to start off with a demo. I think it's important that we can have a mental model of what's going on in the application so that when we spend time looking at the source code, we can refer back to what we saw and understand what pieces of code are doing what in the application. So I'm going to switch over to Xcode, pull up our project, and I'm just going to start the app in the simulator. Now, while this is launching, let me talk to you a little bit about the functionality of the demo. It's a mapping navigation application, and it's going to keep track of us on a trip and allow us to get the current weather, points of interest like coffee, food, and fuel that's near us, as well as receive real-time messages triggered from the cloud directly to us in the application. When you're building a CarPlay application, the app is actually running on your iPhone. You then plug the phone into your car, assuming the car supports Apple CarPlay, and then your phone will then take over the infotainment system in the car. So driving the maps, driving your contacts in your phone, playing music, etc. And the nice thing is you can also build your own apps and have those deployed and run in the car. So it starts with the iPhone app. You can see this on the right-hand side. And then we also want to see what it's going to look like in the CarPlay simulator. And to do that, once the iOS simulator is running, you simply go to the I/O menu, External Displays, and then select CarPlay. And that'll bring this up and it'll simulate connecting to the car. Another thing we want to use in the simulator is the ability to simulate a trip. Right? We want to see the information for our location that we are currently at. Now we can get that for our current location, which is static. However, we want to see it change and how our application works as you are driving around. So to do that, you go to Features, Location, and then Simulate a Freeway Drive. What this is going to do, it's actually just going to simulate a drive from Cupertino to San Francisco. And then as the location changes, our application can display different information based on the current location. So for as far as the functionality is concerned, we can click on the weather icon, or the weather button, and it'll talk to our backend services and determine our city, the current temperature, and the air quality index for that location in Cupertino. We can also click on the Places button. The Places button will show us the closest fuel, coffee, and food to our current location. And finally, there's a Messages button. And I'm going to show this functionality actually in the CarPlay side. So now if we want to see the same information or the same functionality running in CarPlay, we just tap on the icon, which will be in the infotainment screen in the car. And we'll see a similar functionality, right? We see ourselves driving down a path on a map, down the highway. If we tap the screen and click the weather icon, It's going to show us where we're at, the temperature and the air quality. If we click the places icon, we'll choose from coffee, food, or fuel. This will show us the closest food. I think if you notice, this list is a little different than when we saw on the iPhone app. And in fact, it just changed in real time, because as we're moving, things are becoming closer to us as we move through space. And so you can pick one of these, and then it'll give you a navigation alert in which you can say, I want to go to that location. Now, in this demo and in the source code that I'm going to provide you, we didn't take it as far as hooking in navigation turn-by-turn instructions, but I'll show you in the code where you could easily fork this and extend this functionality if you want to add that type of functionality. So the last thing I want to show you on the app's functionality is the concept of the real-time messages. So I'm just going to move this screen over here, and I am going to go to the AWS console in my AWS account. I'm going to try to see so I can show both of these at the same time. And what I'm doing here is I'm navigating to the AppSync service. So within your AWS account, you can go and pull up the API that you've built. And then there's the ability to run queries. And I'm going to run what's called a mutation. A mutation in AppSync and in GraphQL is creating, updating, or deleting something. It's called a mutation. I am going to create a vehicle message. So I'm basically calling the create vehicle message API method of my API. I'm going to have a message that says, pick up a package. I'm going to send it to vehicle 1 and give it a timestamp. And when I do this, it should show up instantaneously in my application. So I'm just going to run that mutation to create the message. And boom, if we look over in our application, it popped up immediately. Now notice, this is in the cloud, and this is local on my machine, or it would be in your car. And we're going to talk about this concept, and it's called subscriptions, which is a feature of GraphQL that allows you to do this real-time messaging between the cloud and your applications. Okay, so now I'm going to stop the simulator, and let's go take a look at what it took to build this. So the first thing I want to point out is just call attention to the Amazon Location Service. This is a new service that was launched at reInvent last year. It's a managed service that allows you to bring location-specific information and functionality into your applications. So for example, you can use it for your map tiles within your application. You can use it for what's called geofencing. That's where you can define a virtual fence using latitude and longitude coordinates, and then have events triggered in your application as users approach, enter, or leave those virtual fences. You can do tracking by, for example, tracking packages, right? And then you could see the history of that package as it went from location A to location B and simulate the results. You can do routing, so you can get turn-by-turn instructions from place A to place B. And finally, you can do place indexes, which is what we're using in our application. So the ability to pass in your current latitude and longitude, what you're looking for, maybe it's coffee or food or fuel, and then it'll send back the results that are the closest within your location. Now, Amazon Location Service is powered by partners. So two of the primary partners today are Esri and Here, and they're providing all that content, that geolocation information and functionality through the Amazon Location Service. Now let's take a little look at the architecture of the overall solution. We'll start from the left and we'll move to the right. As we saw before, the foundation this is an iOS app that's built in Swift. That application is talking to AppSync, which we saw in the AWS console. AppSync is AWS's managed GraphQL server. We're going to use that for our API. All interaction between the iOS and the cloud, the app and the cloud, will go over the AppSync gateway. In GraphQL, we'll be executing queries, which is when we request information, as well as subscriptions. And that's how we obtain the real-time updates from the cloud with those vehicle messages. Now, GraphQL also works on what are called resolvers. And resolvers may be how to interact with other components. So for example, how to save data and retrieve it from DynamoDB, which is where we're storing our vehicle messages. It's also how we can wire up to AWS Lambda functions to go out and get data from pretty much anywhere. So we're going to walk through a couple Lambda functions that we have, one that connects to the Amazon location service and pulls in information for there, and a second that goes actually outside of AWS and talks to a third-party weather API. Now, we're also going to use the AWS Secrets Manager. AWS Secrets Manager is a secrets vault service. So you can store things like database usernames and passwords, or connection strings. In our case, we're going to store an API key for the weather API, because we don't want to hard code that into our source code. But what we can do is we can store the API key in a secret, and then at runtime in our Lambda function, we can pull the secret out and use it in our call to the third-party weather API. Now, I'd like to explore the source code of the application and break it up into 3 groups. First, we'll look at the backend, then we'll look at the API layer, and then finally, we'll look at the front-end code. Now, I'm not going to go over every single line of code. It's just too much, and we don't have enough time to do that. But at the end of the presentation, I'm going to give you a link to where this source code is posted in GitHub under AWS samples. And then you can download that. You can clone the repo. It's got a very detailed README file, which will take you step by step on everything you need to run this application locally. But I will, in this presentation, highlight the bits and pieces of the code that I think are really relevant and germane to what it takes to build this kind of application. So let's start with the backend. Here we're going to talk about the data sources, which we already alluded to, the location service and the third-party weather API. We're going to take a look at how you build a Lambda function in Swift that talks to these services. We're going to talk about Swift Package Manager, which is how you scaffold out your Lambda function and then pull in third-party dependencies and libraries that you want to utilize. We're going to talk about some other new functionality that was launched at reInvent, which is the ability to deploy your Lambda functions as Docker images. And this has really made the deployment and the development of Swift-based Lambda functions really easy to do. And then finally, we're going to look at the Cloud Development Kit, which is our AWS's infrastructure as code offering that allows you to define your backend environment in code. And for example, in Python or TypeScript or Java, and then run that and have it create your infrastructure for you. So let's take a look at some of the backend code. Okay, so the first thing I wanted to do was talk about how you scaffold out your Lambda function. So you want to create a backend Lambda function. You're going to use the Swift Package Manager. And the command to do that is Swift package init type executable. And what that will do in your current folder is it will scaffold out the files that you need for your Lambda function. Now, I've already got a couple created, so we don't need to actually run that command. But let's pull one up that I created for this application. So I created a folder called Lambda and functions. And then here's the code for my 2 functions. So I have one for get weather and one for get places. Okay. And these are the files that were scaffolded out by the Swift Package Manager. The first one that you're going to want to be familiar with is the package.swift file. This is your dependency file. So similar to other languages, let's say you're working in Node and you have the npm package manager and you have your package.json file where you define the libraries you want to pull into your code. This is the file where you define that for SPM. Okay, there's a couple different sections you'll want to know about. The first is where you define the packages. Now, for SPM, there is no global package repository. The packages are actually stored in Git repos, so typically in GitHub. And so the reference to the package is actually the URL to the repo itself. Now we're going to focus on pulling in 3 libraries for our first function. First, we're going to pull in the AWS Lambda runtime. That's going to have all the bits that are needed to turn our code and let the Lambda runtime in AWS execute our function. Then we're going to pull in the async HTTP client library. That's going to allow us to make RESTful API calls to our third-party weather service. It's just going to have methods for constructing HTTP calls, gets and posts and puts. And then finally, we're going to pull in this package called SOTO. So as of right now, AWS does not have an official Swift SDK. So if you've done work on AWS, you know we have SDKs in a wide variety of languages, Java, Python, JavaScript, etc. We don't have one for Swift yet. We're working on one. I'm hoping that it'll be released this year sometime. But in the meantime, there's a great open source version called SOTO. And so we're going to use that. And that's going to allow us to programmatically interact with AWS in our Swift code. Now down here, we're going to specify the specific libraries that we want to pull in. For these first two, the Lambda runtime, it's just basically the Lambda runtime. Same with HTTP client. But for SOTO, we only want to pull in the secrets manager SDK pieces. That's the only thing that we're going to need out of that package. So now that we've defined our dependencies, the next file we'll want to look at is the Lambda function itself. And so that's found under the sources folder in a file called main.swift. And this is our Lambda function. So at the top, and if you're familiar with Swift, you'll recognize the code. At the top, we do our imports. So we're importing those libraries that we just defined in our package file. Then because Swift is a strongly typed language, we need to define structs for all the input and output of our function. So for example, we need to define the event and arguments that are passed into our function. So that is the latitude and the longitude. We're basically on our API call, we're going to say, give me the weather for this latitude and longitude. Then we define the output. We define that this function will return the temperature, the air quality index, the latitude, and the longitude. And we use that information to display on the weather screen. We also have to define the API response that we get from the weather API. And so this is driven based on the JSON result that we get back. We want to convert that into a struct so that we can interact with the objects in a strongly typed manner. And so this is the information. We're ultimately getting the air quality index and the temperature. Okay. Now down here, the next thing we do is we establish an AWS client, and this is needed for the SOTO library. So this is our AWS client to interact, in our case, with the secret manager. So we're going to instantiate the client. We're going to tell it to get the credentials from the environment, from the runtime environment of Lambda. That's the APIs or the access code and secret that the SDK needs to interact with and have permissions to talk to the backend services. We're going to execute a defer statement. This will get run at the end of the execution of the function. That's why it's called defer. And it will shut down the client. So we're just making sure that that is shut down at the end of the execution. Now here's where we define the lambda.run, which is what Lambda will invoke when the function is called. It passes in a context and an event, which is similar to other Lambda functions in other languages. And then we have a callback, which is how we exit out of the function and return the results. We're going to use the Swift construct of the result type, where we either return a success or a failure. If it's a success, we'll return the output object populated with data. If it's a failure, we will return an error object. Okay. We're going to grab a decoder so we can decode the JSON that comes back from calling the weather API. Next, we're going to pull in some environment variables. So if you're familiar with Lambda, you have the ability to define environment variables for your function. This lets you avoid hard coding environment-specific information into your code. You can pull it from an environment variable that you populate, and therefore you can use the same code and point it to different environments that may have different values for those environment variables. So for example, we're going to store the API endpoint. That is the endpoint, the URL to get to the weather service. we're also going to store the API key's secret name. So not the key itself. We certainly don't want to store, an API key in our source code. We're also going to store in an environment variable the name of the secret. So inside the secret, we're going to store the API key. And here, we're just going to pass from an environment variable the name of that key so we can invoke it. And that's what this next line of code does. So we are going to invoke from the SOTO library, the secrets manager object. We're going to pass in the client. We are then going to pass in the name of the secret that we want, and we're going to ask for the value. It's asynchronous, so we will invoke a wait command. And then when that returns, we will pull out the secret string, which is our API key. Next, we are going to construct the RESTful API call to talk to the weather service. So it's just a GET. So we just need the URL. So we'll construct that with the API endpoint. Then we'll pass in a few parameters, the key, the API key, as well as the latitude and longitude. So what we're saying here is give us the weather. Here's my API key, so I have permission to make this call, as well as here's the latitude and the longitude for which I want the weather. Then we are going to construct an HTTP client so that we can make this RESTful call. We'll execute another defer to shut down that HTTP client after it's done. We'll invoke the get method, and then we'll wait for the response. When we get the response, we'll use the decoder to decode the JSON into a strongly typed object, which was our API response object. I threw in a little logic here. You don't have to do this necessarily, but I wanted to show that we could convert the temperature. It comes back from that API as Celsius. I wanted to convert it to Fahrenheit. So I just put a little formula in there. And then finally, we'll do a callback. If it was a success, we'll return the output object with the temperature, air quality, etc. And if we caught any errors, we will execute a failure return and then pass in the error object. Finally, we just have a function here that will allow us to pull out the environment variables, which is pulling it from the Lambda process. Now that we've written the code for our function, the next thing we want to do is we need to be able to turn it into a Docker image, because we're going to deploy this to our AWS account as a Docker image. So to do that, you need a Docker file. What we're going to show here is how we use what's called a multi-step Docker build file. So here's our Docker file. This is where we define how we're going to take that Swift code, compile it, and turn it into a Docker image that we can then deploy to our account. We're going to do it in two phases. First, we're going to use Docker to compile the source code into an executable. And then we're going to copy that executable into another image and load that into our AWS account. And I'll explain to you why we're going to do that in a second. So for starters, we're going to pull down the Swift image from Docker Hub, running with a base image of Amazon Linux 2. We're going to copy over our source code, our source file that had our Lambda code in it. We're going to also copy over the package.swift file. And ultimately, we're going to do a Swift build on that code, which will then create the executable. Now, from here, we could probably wire things up a little bit more and then deploy this image to our AWS account and run the Lambda function. However, this image has the entire Swift SDK in it. We don't need all of that. It's way too much bloat to deploy in our image. We really just need the final executable. So we're going to use this image to do the compilation. Then we're going to take a second image, which is the Lambda image from the AWS's public container registry. Okay, this is an base image that has the bits in it that are needed for it to execute as a Lambda function. And what we're going to do is we're going to make a few folders that are needed by Lambda, this task and runtime. And then we're going to copy from builder. So up here, we defined this image as the builder. We're just going to copy that executable out and put it into this file, Lambda exec, on this destination image. Then we're going to change some permissions on to make the file executable. We're going to make a symlink to this bootstrap file that Lambda will be looking for. And then ultimately, we'll tell it the command to run our function. And then this function is what's going to get deployed to your AWS account. It doesn't have the Swift SDK in it, so it's much, much smaller, probably about a third of the size. And it'll execute and be much more efficient in your Lambda environment. Okay, so now that we've defined the Docker file, the last thing we want to look at is how we get this image and this infrastructure into your AWS account. And that is using the CDK. So in the CDK, and the CDK is just installed on your build or development machine as a node package, a global package called CDK. When you use that to scaffold out your CDK project, it's going to create a file, a stack file. Now, I've used TypeScript for this. You could also use Python. You could use Java. You can't use Swift yet in this. The first thing we're trying to tackle is the Swift SDK. Then we'll go and take a look at if we can get Swift supported in the CDK as a language for defining your infrastructure. So for this portion, we'll be looking at it in TypeScript. So up here, I've imported the libraries. These are NPM packages from the CDK that I need to use. So I want the core package. I want the package to create a Lambda function, IAM, and then secrets manager, because those are the objects I want to create in my AWS account. Then in the stack file, this is the file that where you code up your infrastructure. So first, I'm going to create a new secrets manager secret. Then I am going to create my first Lambda function. And what's nice is this Docker image function on the Lambda object. All I really need to do is pass the location to the path of my Docker file, and then it will take it from there. It will build the Docker image, upload it to the container registry in your account, and then create the Lambda function from the image. Now I'm going to give it a few more instructions. I'm going to pass in a build time argument of the name of the function, the location of the executable that I want built. I'm going to pass in the timeout for the Lambda function, how much memory I want dedicated, and then I'm going to pass in the environment variables. So I'm going to pass in the secret name. What's nice, I can just get the name from that secret object that I created above. And I'm also going to pass in the API endpoint that I'm storing in a context file. Finally, I am going to use the secret manager object to grant read permissions to the secret to the Lambda function. So I'm saying secret, grant read, and then passing in the function object. And that will then create the necessary IAM permissions for my function to interact with the secret manager. I'm then going to output the name of the secret. That'll be displayed when I execute this stack. So then I know the name of the secret that was created. So then I can either go into the AWS console or from the command line and populate that secret with the API key. And then the rest of this code is just doing something similar for the second function, which is to get places, where we define the Docker file, set some environment variables, and then give it permissions to talk to the Amazon location service. And then once I'm all done with this, I can execute a CDK deploy command. The CDK deploy command will then take this code, turn it into a CloudFormation template, load that to my account, and then create this entire infrastructure. It'll also build the Docker image locally and then upload that, as I mentioned, to the container registry. So that's what I wanted to show you for the backend code. Now let's take a look at the API. As I mentioned before, we are going to be building that with AWS AppSync. AppSync is our managed GraphQL service. We're going to look at how we define that API in what's called a model schema file. We'll then look at how we wire up the API calls to the Lambda functions that we just built. Those are called Lambda resolvers. Finally, we'll look at how you define a query and a subscription, and then how you use Amplify to deploy that API to your AWS account. We're going to be using one aspect of Amplify called the CLI, the command line interface. So let's take a look at some of that code. So let's first take a look at how we use Amplify. So Amplify is used to pull in AWS services into your front-end application. So you can do things like Amplify add API. This is what we will do to add the API and create the API in our application. There's other things you could do like Amplify add authentication. Let's say you wanted to use Cognito for a username and password for your application. Or maybe you wanted to store photos in an S3 bucket. You could say Amplify add storage. Now, for our case, we're just going to use it to build out the API. Now, I've already run this command in this project. And what it did was it created this Amplify folder and the Backend API. And the file that I want to take a look at is this schema.graphql file. This is the file where I went in and defined what the API objects and methods are. So for example, I've defined a vehicle message object. This was the message that came in real time and was displayed from the cloud, triggered from the cloud and displayed in the application. So it has an ID, the properties are the owner, the timestamp, and the message itself. We're defining a weather object, which has the air quality, the temperature, the latitude, and the longitude that will be returning from API calls. The place and the place types. So you can do enums when you're defining your objects. The enum is city, coffee, fuel, or food. And our place object has a place type, a name, an address, and the latitude and longitude location of that place. The next is where we map the queries of our API to the Lambda functions. So we're going to say we're going to have a get weather API call. It's going to take parameters of latitude and longitude. It's going to return a weather object that we defined above. Then here we're going to, using the function directive, we're going to wire it up and say when this get weather API call is made by the application, invoke the Swift CarPlay location get weather function, which is the function we just deployed earlier. We're going to do something similar with get places. And then down here, we're going to define our subscription. So subscriptions are triggered when a mutation takes place in your AppSync API. So we're going to say when the create vehicle message mutation takes place, we're going to trigger an on create vehicle message subscription. We're going to pass in, when we start the subscription, we're going to pass in who we are as the owner. So we only receive messages sent to us. And it's going to return a vehicle message object every time the create vehicle message mutation is invoked. And we saw that when we went online in the AWS AppSync console, we triggered that mutation, and then we saw the subscription deliver in real time that information right into the application. So now that we've defined our API, the command you would use to deploy it to your account is Amplify push. Now, I'm not going to run this because I've already deployed this. We saw it running in the demo. But when you run Amplify push, it will take this definition. It will create all the backend resources that you need. So in our case, it's going to create a DynamoDB table to hold the vehicle messages. It's going to create the AppSync API, et cetera, wire it up and connect it to the Lambda functions. And then the next command that we're going to run is Amplify CodeGen models. What this is going to do is it's going to generate the configuration and Swift files that our front-end application need to interact with the API. So it's going to create struct files that map to place type and place and weather objects so that we can interact with the API programmatically using Swift. We'll take a look at that next. So that takes us to the front end. So a few things that we want to explore on the front end of the application are the use of Amplify libraries. So we looked at the Amplify CLI initially, which is how we scaffolded out our API. Now we're going to use Amplify iOS libraries that are Swift-based to interact with that API. We're also going to look at the app lifecycle of a CarPlay app. We'll look at how we built the iPhone piece using Swift UI. And then we'll look at how you drive the screens for the CarPlay using what are called CarPlay templates. And then finally, how we used Apple core location to determine our current location as we're driving and surface the current latitude and longitude that we can use in calling our backend API methods. Okay, so let's switch back over to our code. I am going to pull up Xcode for this portion. So the first thing you'll notice when you load the project in Xcode is it lists our Swift package dependencies. So prior to, I'd say, April of 2021, you would import the Amplify libraries using CocoaPods. But in April, we released the ability to import them as Swift packages, which is really nice now because we can use the exact same package manager for our backend code. If you'll recall, that's how we pulled in the libraries that we used for our Lambda functions. Now we can use the same package manager on our front end code as well. To add those to your project, you go to File, Swift Packages, add a package dependency, and then you put in the URL to the package that you want to import. And remember, those are the GitHub URLs to the repo. So I've already done that for our project, importing what Amplify needs for our front end. If you'll recall, we executed that Amplify model code gen models command, and what that did in our project is it created out a couple folders. It created out this model Amplify models folder, and it's an example of the Swift objects that it created that we can then use in our application. So it created one for the place object, for example. It created one for the vehicle message. And now when we make calls using Amplify to our API, it will return these strongly typed objects that we can then use in the screens of our application. Okay. Now, when you're building a CarPlay application, one of the first things you need to do is define the entry points to the application. So if we look at the info plist file, this allows you to define multiple windows to your application. Because if you'll recall from the demo, we have the application running on our iPhone, but then we also have windows to the application, similar functionality displayed in CarPlay. And to do that, you need to configure multiple entry points to your application. And so under the application scene manifest key of your info file, you can define enable multiple windows as true, and then define those entry points. So the application session role we'll say is started by the scene delegate file in our project. And then the CarPlay template application scene is driven by the CarPlay scene delegate file in our project. The other thing you're going to need to do is request permissions from the user to use their location. And you do that by adding this key to your info plist file, which is the privacy location when in use description key. And then you just put in the text that you want to be displayed to the user when their permissions are requested to use their current location. One other thing I want to point out, that if you're going to be building a CarPlay file is, and it's not defined in here, but you do need Siri enabled on your development machine. If you don't, you're not able to run the app in the CarPlay simulator. So you'll want to enable that on your laptop. Okay, now that we've looked at how we define the entry points to the application, the next thing you need to know about is the entitlements file. So when you're going to build a CarPlay application, you define a file called entitlements, and then you indicate what aspects of CarPlay you want to use in your application. And so we're going to use navigation entitlements, which is listed as CarPlay-maps, but you could also be building out maybe an EV charging that has an entitlement, or a audio playback, or a food ordering application. Those are all various entitlements that tell Apple what kind of functionality you're going to run in this application. Now, if you're going to deploy this to the App Store and in production, you're going to need to get those entitlements approved, and you do that in your Apple developer account. But just to work locally, you really just need, and to test it out and do a POC, you just need to define this file, put in your entitlement. You can get a list of the entitlements on the Apple developer site. And then you need to just go into the build settings of your application, go down to the signing piece, and then make a reference to where that entitlements file is in your application. Okay. Once you've done that, then you can, when you run the application in your local simulator, you'll be able to invoke the CarPlay screens and see your application running. Now, we talked a little bit about the entry points. So from the app lifecycle perspective, that starts with the app delegate file. In here, all we're really doing is initializing Amplify. So we're going to import the Amplify and the API plugin, and then we're going to invoke them and then pull in the local configuration. That's all we're really doing in the app delegate. In the scene delegate, which remember is driving the iPhone app experience, all we're really doing is invoking the Swift UI content view. This is really the main piece of code. And then finally, we have the CarPlay scene delegate, and the CarPlay scene delegate is what drives all of the screens in CarPlay. Now, one thing you'll need to understand about CarPlay is you don't have fine granular access over the UI. So on the iPhone side, you can design your screens, you can put things wherever you want. You can't do that in CarPlay. In CarPlay, you're working with a series of published templates. So for example, we have the map template and list templates, and you can provide data to those templates, and you can handle the events that users take in your application, like tapping on buttons. And we'll look at this in a second. Let's start by taking a look at the iPhone app. So we said that started in the content view. All we're doing in the content view is invoking the map view. Normally in the content view, you may be checking for authentication, and if they're not authenticated, launching a login screen. And then if they are authenticated, proceeding into the rest of the functionality. We don't have authentication, but I wanted to keep that construct here in case you were starting with this code and wanted to extend it and add that in here. But we're really just invoking the map view screen. And the map view screen is that main screen that you saw in the iPhone. We're invoking a vehicle message service that we created to receive the real-time messages. We are also declaring a location service. These are both observed objects, so that when the information they receive changes, like a new message is received or the core location changes, these objects will be automatically updated, and we can get the latest values from properties on these objects. Then we're going to declare a few state variables that control, showing the pop-up screens. We define the map in the main body of the view. We say that we're going to be tracking the user's location. Then we display that from the location service, the current city. And again, that will change in real time as the city changes. And then we put our 3 buttons at the bottom. If you'll recall, we had a button for map, or for the weather view, for the places view, and then to see the real-time messages. So the rest of these files and views are just similar for defining the screens and certain buttons, etc., using Swift UI. So that takes care of the iPhone piece. Now we'll look at the CarPlay scene delegate. So again, this is where you define all your CarPlay templates. We're going to define that we're going to use a map template, right? The main screen was a map. We're going to define a series of list templates to display a list of nearby coffee, fuel, and food. And then finally, we're going to use the information template, which I found was a nice way to lay out the weather screen. We've got some delegate methods that are invoked when the CarPlay starts up, where we will initialize the templates. We'll just kind of give them a title and empty out any data in them. And then next, we will invoke our 2 services, because in the CarPlay, we're also going to want to know when the location changes or when we receive a new vehicle message. to the application. Here, the rest of these functions are interacting with elements on the CarPlay screens. So for example, this is where we define getting the map bar buttons. So across the top of the map, when we had the weather and the places icons that we tapped, we define those as buttons, we give them an image, and then we have a handler that says when, for example, when the places was clicked, we will push a new template to the stack and display the places grid. Or for weather, we will display the weather icon, and then when it's tapped, we will add the weather template to the stack. This code here, this just defines that places grid. Remember the 3 buttons for coffee, food, and fuel, as well as handling what should happen when you tap one of those. So when we tap on coffee, we will push the coffee template to the stack, which will then list the nearby coffee locations. This is just another delegate for when you disconnect from CarPlay. Okay, and here you'll see the init templates function. We saw that was initialized at the top when CarPlay loaded. In this function, we are just giving each of our templates a title and then an empty array of values. So we've got our coffee template, our list template, our fuel, our food, and our weather template. Then the next thing we need to do is write the functions that will populate those templates with data. So they're going to call the API that we deployed. They're going to use the Amplify libraries to do that. And then we'll take those results and then populate the templates with the data. So for example, the first function is get places. So get places is going to call the get places Lambda function that we wrote. If you'll recall, it takes parameters of a place type. So let's say coffee. We'll pass in the latitude and longitude of the current location of the driver. And we'll say we want 3 results back. I felt 3 was a good number of items that fit nicely on the CarPlay template screen. As we call that function, we'll get a result. If it was a success, we'll then iterate through the array of places that it returned. We'll create a list item for each. And then we'll also create a handler for that item. So the handler will be invoked when the user taps on the item. And the first thing we'll do is we'll pop to the root template. We'll get rid of the list screen, take us back to the map screen. And then we're going to launch a navigation alert. And if you'll recall, when we were doing the demo, this was the little screen that popped up with the go icon or the go button. And I said, this is where you could possibly extend this functionality, add in driving instructions, turn-by-turn instructions to that place. Now, we didn't take this demo to that level. However, this is where you could go in, identify the place that was clicked or tapped by the user, and then add code to initiate those driving instructions. Okay, we have similar logic for when to get the weather, where we pass in the weather template, the parameters that we need. It invokes the get weather API call, handles the result, and adds that data to the weather screen. And then finally, at the bottom are a few delegates that we handle from the location service and the vehicle message service, so that we receive these events when the location changes. Then we can refresh all of the list screens. And if we get a new vehicle message, we can do a pop-up alert and display the message to the user. Okay, so now that we've looked at all the code, I just want to thank you for your time. I personally really enjoyed not only building the application, but showing you how I did it. Hopefully you learned something that you can take away. Maybe it is how to build Swift-based Lambda functions and deploy them as Docker images to your account. Maybe it's the Amazon location service where you can start pulling location-based functionality into your application. Or maybe it's some of the nuances of building a CarPlay app that will help you get started on that journey. I'd like to thank you for your time and say good luck in your future projects. Thank you.